Welcome back to Easy Learning. In our last video, we were discussing about polynomials and zeros of a polynomial. Now we are going to discuss about the relationship between zero and coefficients of a polynomial. So, for example, you know what is zero of a polynomial? Zero of a polynomial is the value of x at which p of x is 0. Zero is value of x at which p of x is 0. This is a zero of polynomial. Then what are coefficients? Coefficient of a polynomial, suppose p of x equals ax square plus bx plus c. Okay, then what are coefficients? Coefficients are the constant terms with the variables. Here a and b are coefficients. They are the constants with the variables, and c is the constant. Okay, coefficients are the constants. They will be also real numbers. A, b and c will be real numbers. That real numbers with the variable is called the coefficient, and the constant term. For example, if I am writing x plus 5, here x is the, or if I write 2x plus 5, 2 is the coefficient of this variable and 5 is the constant term. Number without variable is a constant term, and the number with the variable is the coefficient of that variable. Is it clear? So now we are going to discuss about the relationship between zero and coefficients of a polynomial. Without actually doing the algebraic, without actually using the algebraic method for finding the zero of a polynomial, or we were used with the graphic representation, we can easily find the zeros of a polynomial by using the coefficients of that polynomial. There are some equations related to that. So now we are going to discuss about that equations. How to easily find out the the zero of a polynomial using this, or how we can suppose sometimes in your questions it will be given the equations related to coefficients, then we'll be asked to find out the polynomial. Suppose for finding the quadratic equation will be given the equations or the coefficients, that equations will be given or that values will be given, and we need to find out the polynomial. Okay, we are going to discuss in detail about that. For example, consider a linear polynomial. Linear polynomials are those with degree 1. Consider a linear polynomial x plus 5. Suppose p of x equals x plus 5. So how to find out the zero of a polynomial? We need to equate this polynomial with 0. So x plus 5 equals 0, then x will be minus 5. When x becomes minus 5, the value of p of x will be 0. So 0 of this polynomial x plus 5 is minus 5, value of x. So without actually doing this, we can also find out in another way, that for any linear polynomial, zero of that polynomial is x. X equals minus, for linear polynomial, I'll write the general form of linear polynomial, it is ax plus b. This is the general form of linear polynomial. It is ax plus b. For any linear polynomial ax plus b, x equals, okay, minus b by a. X equals minus b by a. That is, if you are considering this equation x plus 5, what will be the value of x? It is minus b. Minus b is, here b is 5, minus b is minus 5 by, what is the value of a? A is 1, right? It is ax plus b, a is 1. Minus 5 by 1, which is equal to minus 5. Look, we already got that x equals minus 5. So without actually doing all these calculations, we can easily find out the value of x at which the equation at which a polynomial p of x will become 0. For any linear polynomial, x equals minus b by a. So this equation you have to remember, x equals minus b by a for any linear polynomial. Is that clear? You can just note it down. For any linear polynomial ax plus b, I am just writing the general form so that you can easily identify the values of a and b. So it will be more easy. X equals minus b by a okay. So for linear polynomial x equals minus b by a, this is the relationship between 0 of a polynomial and coefficient of that polynomial. These are the coefficients of this polynomial, isn't it? B and a are the coefficients of this polynomial. So this is a relationship between x, that is 0 of the polynomial, and coefficients of the polynomial. Now let's move on to the quadratic polynomial. We know that for quadratic polynomial we will be having two zeros of polynomial. Why? Because we already learned that degree of a quadratic polynomial is 2. So at most there will be two zeros of polynomial, isn't it? Then so there will be two zeros of polynomial. I am writing the general form of a quadratic polynomial. It is ax square plus bx plus c, where a not equal to 0. We will be having two zeros of polynomial. So we are using two variables, alpha and beta. Alpha and beta to denote zeros of polynomial. Zeros of polynomial. Okay, we are using alpha and beta to denote the zeros of this polynomial. Since it is a quadratic polynomial, we will be having two zeros of polynomial. So we are using the variables alpha and beta to denote the zeros of a polynomial. Okay, here we have some equations connecting zeros of polynomial and the coefficients of polynomial. Here the coefficients are a, b and c, isn't it? These are the coefficients of this polynomial ax square plus bx plus c. It is a, b and c. So alpha plus beta. Okay, we have one equation, that is the sum of zeros of polynomial alpha plus beta is equal to minus b by a. Alpha plus beta will be equal to minus b by a. Minus b by a means we can write in general form, minus of coefficient of x by coefficient of x square. Okay, alpha plus beta, we have two zeros of polynomial, we are denoting it with alpha and beta. So alpha plus beta will be equal to minus b by a. Minus b by a means minus coefficient of x. Here what is b? B is the coefficient of x, and what is a? It's the coefficient of x square. Okay, then alpha beta will be equal to c by a. Alpha beta will be, that is product of the zeros of polynomial is c by a. C by a is constant. C is a constant, right? Constant by coefficient of what? A is coefficient of x square. So these are the equations which you have to remember for a quadratic polynomial. Zeros of polynomial alpha and beta. Alpha, sum of zeros of polynomials is minus b by a. Minus b by a is minus of coefficient of x by coefficient of x square. And the product of the zeros of polynomial is c by a, that is a constant by coefficient of x square. We'll do it some examples. We'll do some examples and it will be more clear for you. Then you will understand it clearly. Okay, let's do one example. Suppose we have a polynomial p of x equals x square plus 7x plus 10. We need to find the value of x. I hope you all know how to solve a quadratic equation. You have learned it before. So what is the method to do the solution? Solve a quadratic equation. So what's the method? We need to equate x square plus 7x plus 10. Isn't it? X square plus 7x plus 10 equals 0. X square plus 7x plus 10 equals 0. How to solve this? We need to split the terms. How? Here it is 7x. That means the product of, when we are splitting, the product of those two numbers should be equal to 10 and the sum should be equal to 7. So what will be the numbers? X square plus 7, right? 5 and 2. 5 into 2 is 10 and 5 plus 2 is 7. So we will make it 5x plus 2x plus 10 equals 0. Okay? 5x plus 2x is 7x. 5 into 2 is 10. This is the way you solve a quadratic equation. I hope you remember all this. Then it will become x square plus 5x, right? Then we will take x as common, x plus 5 plus, here we will take 2, then x plus 5 equals 2 into x plus 5 equals 0. Then this will become x plus 2 into x plus 5 equals 0. That means x equals minus 2, x equals minus 5. So that is x plus 2 equals 0 and x plus 5 is equal to 0. That means x equals minus 2, x equals minus 5. So these are the two values of x at which this polynomial p of x will become 0. That means our alpha equals minus 2 and beta equals minus 5. So these are the two values of x at which our polynomial p of x will become 0. Those two values we are denoting it using alpha and beta. Here alpha is minus 2 and beta is minus 5. Okay. So I'll just write the general form also, then it will be more clear. X square plus bx plus c. Here a equals, what's the value of a in this? A is 1. B is 7 and c is 10. We'll just verify whether this is correct or not. Okay, we need to check alpha plus beta is minus b by a or not. Okay, what is alpha plus beta? We are going to solve the first equation. Alpha plus beta equals minus b by a. What is alpha plus beta? Alpha is minus 2 plus beta is minus 5. Okay, what is minus b by a? B is 7. Minus b is minus 7 by, what is a? Value of a is 1. Minus 7 by 1. That is minus 2 plus minus 5 is minus 7 equals minus 7. LHS equals RHS. That means sum of zeros of a polynomial, of a quadratic polynomial, is equal to minus b by a minus coefficient of which term? X by coefficient of x square. Then we will try this also. Alpha beta equals c by a. Alpha beta is minus 2 into minus 5 equals c is 10 by 1. Minus 2 into minus 5 is 5 into 2 10 minus minus plus 10 equals 10. So LHS equals RHS. Okay, we have verified these two equations. Is this clear? Okay, this is the way we have to do. We have to find the, we have to understand about the relationship between zeros and coefficient of a polynomial. Sometimes we will be given the values of sum of zeros and product of zeros for your exam. That is, for example, alpha plus beta equals minus 3 and alpha beta equals 2. We need to find the quadratic polynomial. We need to write the quadratic polynomial. How we can do that? From this equation we know that alpha plus beta equals minus 3 and alpha beta equals 2. Okay, we know alpha plus beta equals what? Minus b by a. That is minus 3. Okay, alpha beta is c by a, that is 2. We already know the equations connecting zeros of polynomial and coefficient of polynomial. So with that we wrote alpha plus beta equals minus b by a. It is minus 3 as per this question. Alpha beta equals c by a, it is 2. So this we can write minus, I'll write it here, minus b by a equals minus 3. That means b equals 3a. right? B equals 3a. C by A equals 2 or C equals 2a. Okay, B equals 3a and C equals 2a. That is minus B equals minus 3a, minus minus it will become plus. So B equals 3a and C equals 2a. Suppose if we give any value for A, suppose if we give if A equals 1, then B will be what? B equals 3 into 1 equals 3 and C equals 2 into 1 equals 2. So we got the values of A, B and C. If A equals 1, that is if in general if you are writing ax square plus bx plus c, right? P of x is ax square plus bx plus c. If a value of A is 1, then we can easily find the value of B and C. Then our equation, then our polynomial will become P of x equals A is 1. So x square plus B is 3. 3x plus 2. Okay, this will be our quadratic polynomial. If A equals 1, we can easily find out this. Suppose if A equals 2, then B equals 3 into 2 equals 6, C equals 2 into 2 equals 4. Then our quadratic polynomial will become P of x equals 2x square plus 6x plus 4. Isn't it? So whenever we are giving this, we are substituting the values of A, our quadratic polynomial also will change. Suppose if we are taking 2 out from this, it will become x square plus 3x plus 2. Same as this. That means we are, in general, if we are telling, we are multiplying a constant with the polynomial. So in general, we can say our P of x equals k into x square plus 3x plus 2. This k will be a multiple of A. Each time when we are changing the value of A, our polynomial will also change. So in general, we can say P of x equals k into x square plus 3x plus 2. If A equals 10, then k will become 10, then 10 into x square plus 10x square plus 30x plus 20 it will become, isn't it? So as depending on the value of k, our polynomial will also change. So in general, we can say P of x equals k into x square plus 3x plus 2. If we get questions like this, we can solve in this manner. Now let's move on to the cubic polynomial. We are going to check the relationship between zeros and coefficient of a cubic polynomial. In general, we can write P of x equals ax cube plus bx square plus ax plus d, where a not equal to 0. We know that for a cubic polynomial, there will be at most 3 zeros, right? There will be at most 3 zeros. Since the degree of a cubic polynomial is 3, there will be at most 3 zeros of polynomial for a cubic polynomial. So I am going to denote it using alpha, beta and gamma. Alpha, beta and gamma are the 3 variables which we are using to denote the zeros of a cubic polynomial. So the relationship between the zeros of this cubic polynomial alpha, beta, gamma and the coefficients a, b, c and d is like this. Sum of zeros alpha plus beta plus gamma equals minus b by a. Minus b by a means minus coefficient of x square by coefficient of x cube. I hope you noticed every time the denominator will be the coefficient of x cube, isn't it? Before for linear, also for quadratic, also every time the denominator will be coefficient of first term, the term with the highest, x term with the highest exponent, or the x term with the highest power. Alpha, beta, gamma. Alpha into beta into gamma, that is a product of zeros of polynomial, is minus d by a. Minus d by a means constant, minus constant by coefficient of x cube. Then one more equation we have for cubic polynomials, that is alpha beta plus beta gamma plus gamma alpha is c by a. C by a means c is the coefficient of x and a is the coefficient of x cube, that is coefficient of x by coefficient of x cube. These three equations also you have to remember. There will be problems related to this also. There will be given alpha, beta, gamma value and we need to write the cubic polynomial. Or sometimes they will ask to verify the relationship between coefficient and zeros. Okay, then we will be moving on to our problems. This is not a tough chapter, it's very easy. You need to understand the basic concepts, then it will be more easy for you.